I think we left off here, if I remember correctly. If not, this is a good enough place to start and kind of review, because there's been quite a long gap between the first part of these notes and the second. We're talking about quantitative analysis or research design or scientific method for studying American government. And our question is, why are Missouri roads so often bad? Remember, the way we answer political science questions is with theory. You guys had various theories for why Missouri roads might be so bad, ranging from extreme weather, heavy traffic, low taxes, low spending. We want to know the best answer. And to do that, we need evidence. The main types: quantitative, statistical data. That's what we're going to be focused on, obviously, in these notes and in kind of this in-class activity that we're doing through Pear Deck. The other type is qualitative, which frequently, especially in a class like this, would be detailed comparison. And there are certainly other qualitative methods. But detailed comparison, that was the kind of thing that Montesquieu was able to do in a fairly limited fashion, comparing large and small republics. Our focus, like I said, is going to be on quantitative evidence, because that is what you guys are going to be dealing with on the AP exam. And even those of you who are not preparing for the AP exam, one of the things I most want my students to leave here being able to do is make sense of quantitative data. Within quantitative data, we have two types of statistics. One is descriptive statistics. As the name implies, they simply describe something. They're telling us what is happening, what has happened. In the example you saw in the Heimler history video that introduced us to this topic, how many votes did a party get? How much of the legislature did they capture in representation? They're not telling you why any of that happened, only what happened. Those kinds of statistics can be mean, median, standard deviation. In terms of AP exam, it's usually not even that sophisticated. It is going to be data simply visually displayed. Like this. We have this line represents improving quality of roads. This is time, but time here is not an independent variable. There is no cause and effect relationship here. It turns out roads do not typically get better just because they get older and driven on more. So they are just trying to show you what? A trend that is happening over time. The other kind of statistics is quantitative evidence that is inferential. And inferential, just like any time you've been asked to make an inference, is to draw conclusions. In this case, conclusions about cause and effect. And so these types of statistics will always be about at least two variables. And they will be looking at the correlation between those two variables, which is just how variables are correlated, how they do or do not vary together. The example we will use here is not about roads and not about Missouri, but inferential statistics regarding the relationship between income and happiness. So here, our x-axis really does contain an independent variable, or represent an independent variable. That's income in thousands of dollars. On the y-axis, we have our dependent variable, self-reporting in surveys on various ways of measuring happiness in terms of stress, feeling blue, positive affect, which is the opposite of feeling blue. And then up the middle here, we have life evaluation. I assume from, in terms of how many people report a positive life evaluation. And we can see a lot just in this graph. I mean, for one thing, except for life evaluation, everything else seems to plateau somewhere between $60,000 and $80,000. For this one, it pretty clearly flatlines at $75,000. But life evaluation continues climbing. For us to use this, we need to find the correlation. Remember, that's about how variables change together. And we need to be able to describe those relationships. And so one term for a correlation, or way to describe it, is a positive correlation, which means the variables change together in the same direction. As the value for one independent variable goes up, the value for the other independent variable goes up. So in the previous example, we see that as a person's income goes up, they become more likely to report a positive evaluation of their own life. Then there are negative relationships, where as the value of one variable increases, the other decreases, or vice versa. If we were to do a survey of Central High School advanced placement dual credit students, we asked you to report two things: how many hours you have of homework every day and how many hours of sleep you get. We would find a negative correlation between how many hours of homework you have and how many hours of sleep you get. As the number of hours of homework goes up, the number of hours of sleep goes down. That's a negative correlation. I know, because in my junior year of high school, I remember quite frequently waking up having fallen asleep on my pre-calc textbook. And unfortunately for whoever got that book after me, on some occasions, there was a good deal of drool, if I'm being honest. Fortunately, you guys don't go to Benton, and that textbook has probably long since been retired, so I don't think you have to worry about that. We also need to talk about correlations in terms of their strength. A strong correlation has a very close match between an increase in the value of one variable, right, the independent variable, and an increase in the value of the dependent variable. Right, or, of course, the opposite if it's a negative correlation. In terms of what that looks like visually, let's go back to that. A positive correlation that is very strong, essentially perfectly strong. Right, we have a 90-degree angle here. We would have a 45-degree line running from that corner to the upper corner. It would essentially be a one-to-one relationship. In a weak correlation, changes in the independent variable do not closely match changes in the value of the dependent variable. And that's kind of what we see kind of at this breakover point, is the correlation between increases in income and happiness becomes quite weak after this point. Now, if we look at it overall, we would need other things to really say whether it's a strong correlation or if it's just a moderate correlation. Sometimes graphs aren't enough, but graphs are pretty good at telling us things, and that's as sophisticated as we're going to get in this class. You do need to remember, and I'm sure if this is not the first time you have been told this, it will certainly not be the last. Correlation is not causation. And the classic teaching example that teachers love to trot out, and I'm not going to buck that trend, is the correlation between ice cream sales and homicides. As ice cream sales go up, homicides go up. So does Melody need to get out some stationery and start mailing members of Congress and the president, maybe presidents and prime ministers of other countries, to get some kind of international ban on ice cream because it causes homicide? No. Now you can save yourself some postage, Melody, because that correlation is not causation. When is ice cream, when are ice cream sales the highest? Summer. And what's the weather like in the summer? Hot. When are more people out and about with other people? In the summer or in the winter? Summer. What are people's tempers like when it's hot outside? Short fuse or long fuse? Short fuse. Okay, so in the summertime, more people are out and about with other people. Turns out if you are snowed in a blizzard, like what we might get a little later this week, if you're home by yourself and can't get anywhere, turns out you can't murder anyone. For homicide, you need someone else to kill. But in the summer, you're out and about, close enough to kill people. And you're hot, so you're more likely to be angry enough to want to kill people. But you're also buying ice cream. So, correlation is not causation. There's something else going on that's causing people to buy ice cream, and that same thing, or those same things, cause people to be more likely to kill each other. However, if we have a good theory, and this is why I said on the first day, it is important that we have a logical and persuasive theory. If we have that, and we have good correlation in our evidence, then it is good evidence, confirmatory evidence of our hypotheses and theory. But you need to start with a theory and not start by noticing something in the evidence and then building a theory around it. In the AP exam, correlation analysis is going to be very, very basic. The harder part in the AP exam, and you saw this in the Heimler's history video, is that you have to look at the data and try and figure out what concepts are relevant to it. So the analysis is a little different, and we'll practice along that line. For right now, we're going to do some actual practice with visually displayed data. So we look at these two maps, and our dependent variable is the quality of roads. High values on the dependent variable equal good roads. Low values on the dependent variable equal bad roads. And we have two different maps. And in some ways, they're in conflict with one another. And this map tells us that of the 25 states with the worst major rural roads, Missouri is the middle of that bad pack at number 13. However, in terms of overall road quality, based on, and there are different ways of measuring this, based on one measure, Missouri is third in the nation in terms of having the best roads. So, thinking about those two things, please respond to the poll. We'll take about 20 seconds on that just for everybody to get warmed up for answering things in the Pear Deck. Actually, it sounds like you guys, one, I accidentally gave you 30, and it sounds like I should have intentionally given you more. All right, so we got a range of answers. First, values on the dependent variable are high. And yes, if we take that second map, which is not just focused on one type of road in Missouri, the values are high. And it's perfectly fine to focus on that map. Some of you split the difference looking at the two in the sense that they kind of cancel each other out with their contradictory messages about the state of Missouri roads. And this gets at that as well. Rural roads are a large part of our roads. They're the roads a lot of us drive on a lot of the time. And yes, I mean, some of it's focusing on personal experience. And we do have to be careful. I mean, one of the reasons we use statistics is to get away from personal experience. Right? Does that mean our personal experiences are invalid? No. But, I mean, if you've got somebody that lives in Monkey Mountain, north of, like, west of Amazonia, and I don't know why it's called that. I've never seen any monkeys there, but I've driven on it, and it's horrible, right? And the road that leads to it is horrible. If that's your experience, your experience is that Missouri has bad roads. Whereas if you live on a lot of the others around here, like Route W that runs through some like nice housing areas and such, that road's pretty good. Not saying that they don't take care of Monkey Mountain because there aren't nice houses there. There's just not many houses at all there. And then, of course, again, conflicting evidence. Has anybody driven Monkey Mountain? Do you guys have any idea what I'm talking about? I would drive it in good weather, and I mean, oddly enough, I would tell you to drive it when it's been a while since they added gravel to that road, because it's really easy to fishtail and like fly off of a small cliff onto railroad tracks. But it is fun driving. All right. Now some data. Now, if we go with the theory, if we go with the assumption that the dependent variable's value is low, that Missouri does have bad roads, what is the independent variable visible in this data? And I know it's tiny on your screens, and some of you, I mean, even if you're pretty close to the screen, it's hard to read the numbers. But just use the words on the map. What is the independent variable displayed in this data? Let's take about 15 more seconds. Okay. And here your answers are short. You just want to tell me what is the independent variable. We're not talking about values on the variable. We're not talking about its relationship to the dependent variable. We just want to know what the variable itself is. Okay. And it is gas tax rates measured in cents per gallon. Our values for this independent variable, and we're talking here values for Missouri on this independent variable, high or low compared to other states. And to help you out with some of the numbers, and Missouri's tax per gallon is 17.47 cents. Compare that to our neighbors across the border, Kansas, just over 25 cents. Illinois on the other side, almost 66.5 cents per gallon. California, close to 78. And there's another number that gets you to the point faster. We are ranked 49th out of the 50 states. Only Alaska pays less per gallon in fuel taxes. And so as you guys weighed in, the value on that independent variable is low. Would the value on that independent variable support a theory that low fuel taxes cause poor roads? Here, just choose which option you think is correct. Does the independent variable value support a theory that low fuel taxes cause poor roads? All right, you guys evenly divided. Yes, right. Even though this was a poll, it turns out there is a right answer for this, and the answer is yes. If we are assuming that roads are bad because of low fuel taxes, meaning there's not as much money around to maintain the roads, then yes, this would confirm that hypothesis. It would support that theory. It would also be an indication of a positive correlation. The less money in fuel taxes, the lower the quality of the roads. As remember, positive just means they change in the same direction. It can still sound negative in terms of direction if we're talking about less money, poorer condition of roads. Okay. And then there's this, which again, you can't see the numbers, you can't read where Missouri is unless you've got really good eyesight. But again, use the words on there. What is the independent variable visible in this data? And as you're writing this, what I would like you to think about is, remember, variables are things that can vary. So we need to strip this down to the bare bones. What is the thing that can vary on that graph? And then just a representative sample of the answers we got. How much money is spent on highway systems? Which is perfect. We don't want to talk about the variable, or we don't want to describe the variable as states that spend the most money on their highway systems, because now all of a sudden we have automatically constrained how much our variable can vary. For Missouri, are values on this independent variable high or low compared to other states? And to help you out, because again, this is really hard to see, that's Missouri. Third from the bottom, in terms of how much the state spends on its roads. I've got about 2/3 of you in already. Let's take a few more seconds to get those answers in. Okay, and the overwhelming majority of you have said that it's low, and it is low. Now, this gives us some sense. There's a lot of other information in this graph that is certainly relevant. Those blue bars there, those represent spending on, it's kind of weird that they've lumped all this stuff together, and I'm not sure why, but I'm going to guess there's a methodological reason. Highway law enforcement and highway debts are that area of spending. So for some states, they spend a huge chunk just paying for law enforcement and previous debts related to road building and maintenance. Missouri doesn't spend that much on it. Now, proportionally, it's actually hard to say, but there are some big differences in terms of why states spend what they spend. That takes a huge chunk out of what New Jersey is actually spending year by year on new road maintenance and new construction. Would the value on this independent variable support a theory that low spending causes poor roads? Again, I've got about 2/3 of you already. We'll give it a few more seconds. And you're unanimous this time. Yes, it would support that kind of theory. Now, kind of putting this together and really putting it together something more complicated than what we did previously. Previously, I asked you to come up with kind of a one variable theory for why Missouri might have bad roads. In this case, this combines some different things. If we know the values for several variables, and we've already talked about how much money is raised or spent on roads, and we know that Missouri has lots of miles of rural highway. The thing we don't know until now is that Missouri also, in general, has a very large number of miles of state-controlled highway. Only Texas, North Carolina, Virginia, South Carolina, and Pennsylvania have more miles than us. And this is just one measure. And sorry if you don't like that graph. I had to make this one with Canva because nobody had made it for me. I was kind of bummed about that. By other estimates, and again, it depends on how you measure these things. Some estimates show that only Alaska has more miles of state-maintained highway than Missouri. And Alaska is obviously much larger. But this is way different because Alaska is way down there in this ranking. But given those things, miles of state-controlled highway, rural highway, values on the other variables we've seen, should Missouri have worse roads, a lower value on the dependent variable than most other states? And I don't mean should as in we deserve to have bad roads. I mean probabilistically. Is it likely that we would have worse roads than other states? Take a few more seconds to get those answers in. I've got a little more than 2/3 of you. And again, the majority says yes, and the majority is correct. Considering all of those things, Missouri should have roads that are worse than other states. If our theories were correct, that low spending, low revenue causes bad roads. Which again is partly the question. When we're developing a theory, we need to make sure we understand what we are asking about. If we just look at this map and consider the other evidence we've seen, do the data support a theory that Missouri has bad roads because of a lack of funding or spending on roads? And by about a 2-to-1 margin, you guys say no. The data do not support that. I mean, the data certainly suggests that we should have the recipe for bad roads, and yet, overall, we don't. The question then would be, how does Missouri manage to have such good roads on such a small budget? And which is a different question to ask. And for those of you who still, your personal experience is bad roads, trust me, I get it. I've driven on a lot of those bad roads. And then this last one, and I know we didn't see data on all of these, but if Missouri did have bad roads, which variable do you think would best explain why? So most of you still go with low spending. Here, there are no right or wrong answers, exactly. But what I will say is A and B are actually pretty closely related. So one of the reasons that Missouri has one of the largest networks of state-maintained highways is that for some reason, shortly after World War II, rural legislators at the state level were able to convince everybody else and a governor to pass a law giving responsibility of maintaining state highways to the state or county highways to the state government. So all of those letter highways, your A's, your O's, D's, DD's, T's, W's, those are all maintained by the state of Missouri, not the counties that they're in. And so our state has a huge responsibility for roads, a lot of them that aren't traveled by that many people. And if the state didn't maintain them, they would be absolutely horrible because there aren't enough people using those roads, living in those areas to support enough taxes to maintain them. So in defense of Missouri's roads, they really do manage to get a lot done with not a lot of money. And no, I don't work for MoDOT. I do have family that work for MoDOT, but that's not the reason I'm doing this.